So this video is about how to draw organic molecules, and here we'll only talk about the basics. It is maybe not the most interesting topic, but you need to know it to be able to communicate with other chemists. And there's nothing worse than a miscommunication.
What can I help you with, Lord of Darkness?
I'm looking for a date.
The date is Friday, July 13th.
No, I want to meet someone.
Understood. You want to eat dim sum.
Don't you get it? I want to go on a date.
Here we see 2-methylbutane, and you can see 4 ways you should not draw molecules anymore. Here is how you should draw them. Here are the rules. Now, it is very common to see on the internet structures where the terminal CH3 are drawn as well, but none of my organic lecturers use that convention. So I checked graphical representation standards for chemical structure diagrams in National Union of Pure and Applied Chemistry Recommendations 2008, and that is what they say. It is acceptable to add labels to terminal carbon atoms connected to unlabeled carbon atoms, but only when it is possible to do so without overlapping other portions of the diagram. In reality, you will soon find out how dull drawing molecules for your write-up is, and I suspect soon you will be using the rule whatever is quicker is better. The situation is slightly different when you have a methyl group attached to a heteroatom. I will repeat, it only concerns methyl group and only attached to heteroatom. In that case, drawing a line is acceptable, but drawing CH3 or Me is better. And you cannot mix Me and CH3 conventions, so pick one at the beginning of your write-up and just stick to it. In case you get yourself too carried away with omitting hydrogens, I just want to say that you cannot draw a line instead of ethane and a dot instead of methane. I hope this is logical, especially in the last case, because a dot can be anything. It can be a poop made by a fly. Here we have an example of another molecule, neat and simplified. Notice that we always draw hydrogens on heteroatoms. First, we'll draw back the lone pairs. So, nitrogen has a formal charge of 0, 5 valence electrons in the periodic table, and 3 bonds, so it has 2 unshared electrons, that is, 1 lone pair. Oxygen has a formal charge of 0, 6 valence electrons in the periodic table, and 2 bonds, so it has 4 unshared electrons, that is, 2 lone pairs. I would like you to notice that when a carbon center has 4 bonds, then it has a formal charge of 0. And in overwhelming majority of cases, carbon in organic chemistry has 4 bonds. And if carbon does not have 4 bonds, then you'll be able to spot it very easily, because such carbon will have +1 or -1 formal charge, or it will be marked with 2 dots in case of carbene, but I will talk about it in the next video. So, terminal carbons, so-called primary carbons, have 3 hydrogens. We basically saturate the carbon until it has 4 bonds in total. Secondary carbons have 2 hydrogens attached to them, and tertiary carbons have only 1 hydrogen attached. So we can quickly draw hydrogens back if you need to. I know that you might find it strange. I just told you don't draw hydrogens and then I'm telling you the way to draw them back. Well, many reaction mechanism starts with deprotonation of hydrogen that is obviously not drawn. So, if you're not 100% clear where hydrogens are, then you are stuck, and I mean really stuck.
Oh, help and bother. I'm stuck.
Oh dear. Oh, gracious. Oh, well, it all comes from eating too much.
It all comes from not having front doors big enough.
Now it's time for some questions. First, there are a few examples where you need to draw hydrogens and lone pairs. And as I said, this ability is crucial for your understanding, and it's not that hard either. If you want to challenge yourself, then please pause the video, and after 10 seconds or so, I will show the answer. In the second part of the question, there are a few display formulas and you need to convert them into the line angle formula, the one without hydrogens that we talked about early on. Before you start, I have few tips for you. First, draw the main chain, then draw the substituents on. When it comes to drawing the main chain, don't draw it carbon by carbon. Draw it like this, on this diagram. Notice the difference between the odd and even carbon chain. The odd chain, you start down and finish down. The even chain, you start down and finish up. And it's really important because many university students make the chain too long or too short by 1 carbon. If any of your lecturers doesn't insist that you have to know how to do it, I wouldn't spend time learning how to draw molecules in the line angle formula. It will come to you gradually. The most important thing is that you know how to read the line angle formula, which we practiced a few minutes ago. However, if graphical standards in chemistry makes you excited, then you can look through the graphical representation standards that I mentioned at the beginning of the video. I will post the link below. So that is your last challenge. I will post the answers in a few seconds. Good luck and see you in the next video.